Hello everyone in Year 11 PE. How are we today? That's great. So this is our third lesson in the cardiovascular system. We have had a week off doing any work on this, basically because there were some interruptions, and we're also working on a musculoskeletal injury assignment. But what we're looking at today is mainly to do with keeping our body temperature in a state of homeostasis. Okay, so this slide just gives you some basic definitions of what thermoregulation is. So it's a process that allows you to maintain your body's core internal temperature. And what we want you to be able to understand is that the cardiovascular system plays a really key role in this that you might not have been aware of before. So, what is homeostasis? It's the process of keeping the internal environment of the body in a steady state when the external environment has changed. Okay, so an example of this could be the weather has gotten hotter or colder. Another example of this is when you walk into a room that's more heated or a room that's colder. Another example is when we exercise, our body temperature is going to go up, okay? And internally, where our organs are, we still want to keep that temperature in a state of homeostasis. And that's when we know that the body has optimal function and it can do its thing without any issues. Next slide is how do we cool the body? So the body needs to cool down if the temperature outside goes up and also when we do exercise because our body temperature rises as well. And the main thing we need you to understand is what vasodilation is. Now vasodilation, in terms of cooling, it occurs at the skin or close to the skin. So the blood vessels that are under the skin, okay, they widen, as you can see from the picture here, and that increases the blood flow to the skin where it's cooler and allows the body to release heat through radiation. So this is nothing to do with sweat, it's just that the blood vessels closer to the skin, okay, they're going to release heat via radiation. So that's one way we cool the body. The other way is through sweating, which we all would understand that we have sweat glands, okay, and they release water to cool the body on the skin, okay, on the surface level. So obviously, the hotter it is, the more you'll sweat when you exercise, especially if it's very humid. And if you just take a look again, that's a normal artery, that's a dilated artery. I like to compare them to hoses, okay? So that's a wider hose, and that's going to allow more flow through it, okay? So it's like a fireman's hose, I guess, compared to just a regular garden hose, which we'll see a more narrow hose in the next slide. So to warm up the body, okay? When we warm up the body, okay, it's called vasoconstriction, the technique the cardiovascular system uses, and that's the opposite of vasodilation. So as you can see here, the artery constricts, okay? So less blood goes through those blood vessels and more blood, okay, blood flow is going to the internal organs or closer to the center of the body because that's what we're trying to keep warm, okay? We're not trying to get rid of heat now, we're trying to maintain heat, okay? So the blood vessels under the skin contract and become narrow. So they actually contract when they do that, they tense up. And that decreases the blood flow to the skin and we can retain our heat a lot better. The other way that we do that is, obviously, the main one you would be aware of is shivering. The muscles, organs, and brain produce heat in various ways themselves, okay, by their own functions. And if you just look over here, again, that's a normal artery, and that's a more narrow artery, which has been constricted. Okay, so now you have an outline of that. It'll give you a head start on the next slide, which is what we really want you to understand when you exercise. So everything we teach you, it's all great information, but we always relate it back to when we exercise or do physical activity, okay? So when you exercise, the blood flow is greater, and the blood flow is greater to the working muscles. So you increase your blood flow, okay, and that's cardiac output, but the blood flow to the working muscles has to increase, okay? So we're going to open up those channels and increase the blood flow to the working muscle. Okay, and that what happens as a result is that the blood to the organs, kidneys, stomach, okay, for example, the vessels there vasoconstrict, so they narrow, okay, because we want all our blood going to the muscles, and the organs, they can just hold on a second because our body's going through intense exercise and it needs more blood flow to get energy to the working muscles. Okay, so vasoconstriction works in that way. It limits blood flow in some places, and then vasodilation maximizes it or increases it at other places. As you can see down here, so as you can see in the table here, in the pie graph, this is at rest, okay? Importantly, it's at rest. So the percentage of blood flow, and this is based on 5 litres of cardiac output, so 5 litres of blood moving through the body per minute. It's kind of even between the muscles, okay, between the liver, the kidneys, all right, a little bit less for the brain, and then the skin and the heart don't need quite as much in those instances. But as you can see here, when we increase, our cardiac output increases to 25,000 mils, which is 25 litres, which is quite intense exercise, but it's no huge number. It's just kind of a normal number when you exercise at a really high level. The blood flow to the muscle increases rapidly, and all of those other organs, okay, muscles, skin, okay, skin's an organ, liver, kidneys, they all reduce their blood flow. This obviously happens subconsciously, so it's not a thing that you think about doing, but it just happens naturally when you increase your exercise. So we'll go to the next slide. Okay, this is just another picture of the same sort of thing. As you can see over here, it's got the different organs. And at first, when you look at this, you might think, geez, there's a lot in this picture. But if you just have a look at the cardiac output up here is 25 litres, cardiac output down here is 5 litres. All right, it's just another image of what we saw before. It might be more clear to you. So during rest, okay, you've got more blood flow to these other areas, and muscle blood flow is just 15 to 20%, which is normal, okay? And then at heavy exercise, we've got just a lot less to the brain, the liver, the kidneys, the bones, okay, and the intestines, sorry. And as you can see, it goes up to 80 to 85% of your blood flow goes to your muscles, which is a lot of blood, which is needed. And just this quote here is one I just found online, which might help you understand vasodilation and vasoconstriction. So this is what we're helping you try to do, because we know that because this has gone up, okay, the 80 to 85% to the muscles, there's obviously a lot of vasodilation to the muscles there. And therefore, if we're going to digest food, we shouldn't eat a lot before we exercise, because it's just going to sit in our stomach and only digest really slowly. So this quote from the professor is, if you have a meal, okay, you should wait at least a couple of hours, 1 to 2 hours before a strenuous workout. All right, the body needs time to digest the food and obviously then convert it to energy for your exercise. So if you eat something and it's quite a large amount, that's why it doesn't feel great when you exercise straight away. But if you have just small amounts and really sugary foods, it'll actually give you energy, and that's more for an energy systems topic that you'll do in Year 12. So the main thing to understand is that all the other functions going on in the body are going to really slow down. Okay. Moving on. Just the last thing, there's quite a description of this in the textbook. We don't necessarily, it's great to know, it'd be great if you have a look over it in the textbook, but just so that you are aware of hypothermia and hyperthermia, there's steps leading up to these things. So we just want you to know how the cardiovascular system works to cool and warm the body. That's what we want you to know for this topic. But if you want to know what happens in extreme heat, okay, or extreme cold, okay, hypothermia occurs in extreme cold, okay. So hypo means lower, okay, so lower temperature. Thermia sort of means temperature, okay. and it's a dangerous drop in temperature, all right? And you go through frostbite and things like that first, all right? And hyperthermia is elevated body temperature. This is more likely to happen in exercise because there's a lot of sports that are played and like activities like marathons that are run in really hot weather. Generally, when you do a snow sport, you've got all the equipment, but they are in your textbook. We don't necessarily need you to know about them in detail for this topic, but they are great to understand. But the main thing we want you to learn out of this topic is that process of vasodilation and vasoconstriction, which are the functions of the cardiovascular system. And it is good to know, you do need to know the other ways the body cools and warms up the body, but these things are really important, and particularly that our body, which is an amazing creation, by the way, it is able to redirect its blood flow regularly by doing, and that's a subconscious thing. It knows where the blood needs to go and where it's important to go. So now you're going to go on with the worksheet that we've got today. There's some quite challenging questions in there. You probably will need to refer to your textbook for a few of them because it's looking at exercising in elevated temperatures. So we're looking, we obviously want to understand how the cardiovascular system works in that. The other important thing to understand is some information about hydration, okay? Which the questions should get you to just flick over your textbook or get you to understand that. But obviously the blood plays a large role in keeping the body hydrated. In particular, the blood plasma does that. So hopefully you'll be able to delve into how the blood helps the body even more than it already does. And that's all from me. Good luck with it. Thank you.